This is 3-Minute Math with Mr. White. In this episode, we're going to talk about square roots, cube roots, and even beyond. The way I like to explain this is imagine if we started with the number 9, and then we decide to square it, and of course 9 squared means 9 times 9, and that equals 81. Well, what if you wanted to undo that, and you wanted to take that 81 and get the 9 right back? What on earth could you do that? You can't unsquare something. So what you have to use is this concept of a square root. The square root of 81 is 9, and the reason it is 9 is because 9 times 9 is 81. So you don't have to type in the square root of 81 in a calculator, just think what times itself is 81, and the answer would be 9. So for example, the square root of 100 is 10, because 10 times 10 is 100. The square root of 36 is 6, and that's because 6 squared is 36. Okay, let's move on. We could actually have variables under the square root. Imagine taking the square root of x squared. So you ask yourself, what times itself is x squared? And the answer is simply an x. In essence, the square root undoes the square. They are called inverse operations of one another. Now, here's another example. The square root of x to the 6th is, ask yourself what times itself would be x to the 6th, and the answer would be x to the 3rd. And again, here's it laid out, and it's because x to the 3rd squared is x to the 3rd times itself, which is x to the 6th. We can also have a special situation where we have a negative number under the square root, and that's called a radicand. So this is a negative radicand. So you might want to ask yourself, gee whiz, what squared would equal negative 9? What times itself equals a negative? Absolutely nothing. So the answer here is it's not a real number. In fact, they're called imaginary numbers, and we'll deal with that later in Algebra 2. But more on that another time. Now let's move on to cube roots. Cube roots. Let's start with the number 4, and imagine that we cubed it. We would get 64, because 4 times 4 times 4 is 64. Well, what if we want to undo that? What if we want to start with the 64, and we want to get the 4 right back? What on earth could we do? We would do this thing called a cube root, and you notice the little 3 there, that references which root we're talking about. We're talking about a third root here. So the third root of 64 is 4, and the reason that it is because 4 times 4 times 4 is 64. All right, let's look at a few examples here. So this cube root of 27 would be 3, and the reason is because 3 to the 3rd is 27. The cube root of 1000 would be 10, and that's because 10 to the 3rd power is 1000. Now let's move on to having variables under this root. So here we have a third root of an x to the 3rd. Well, the two 3's in essence cancel each other, leaving you x to the 1st. Now what about the cube root of x to the 12th? What times itself 3 factors worth would give you 12? And the answer would be x to the 4th. And the reason is because 12 divided by 3 leaves you 3 groups of 4, so x to the 4th. Now you can also have other roots other than square and cube. Here we have the 5th root of 32, and the answer to that, of course, would be 2. Maybe not, of course. You're wondering, how did I get that? Well, you ask yourself, what to the 5th power is 32? And the answer is 2 to the 5th power. Take a look at this example. This is the third root of negative 8. I want you to notice that it's an odd root here. Now, earlier we said we can't have negatives under the square root, but believe it or not, we can have negatives under the odd roots, like 3, 5, 7, 9, and the reason is because they come out just fine. The third root of negative 8 is negative 2. You can try that in your calculator, and the reason is because negative 2 times negative 2 times negative 2 comes out to be negative 8, so it actually works. The answer is negative 2. So here's another example. The third root of negative 27 would be negative 3. So you can have a negative radicand as long as we're talking about odd roots. Okay, this has been a primer on square, cube, and other roots, as well as the ability to have a negative radicand, that is to say, the number under the radical symbol. This has been Mr. White with 3-Minute Math.